Hello, I'm going to tell you my paired sample t-test and the results I found. So first I looked for various ideas to create a dataset, and I decided to use the temperature difference between October 2019 and 20 in London as my data subjects, as you can see in here. And by analyzing the relationship between these two variables in statistical terms, I try to observe whether there is a significant relationship between them. First of all, when I did the t-test on the existing data, p was 0.7, so there was no significant change actually. So I also conducted the same test on 2x 2019 and 20 labor force participation rates, that is whole another story, but there were too many outliers there. When I removed the outliers, the p-value was again higher than 0.05. Therefore, I did a lot of experimentation and recreated the dataset myself by playing with the data I have. By doing this test multiple times to observe how the change between the data affected the results of the paired t-test. That is why I use my imaginary dataset for London's October weather 2019 and 2020, as you can see it in here. First, I imported my sample file into Jasp from here and check my assumptions. We have 4 assumptions for this test, and first 2 of them are those: one dependent variable that is measured at continuous level, 2, one independent variable consisting of 2 categorical related groups or matched pairs, should be matched pairs. So since my dataset is not very large, it was easy for me to check whether my data is correct manually. First I checked that, and the variables we see numbered in the left column are temperatures, and then I calculated the difference between these temperatures, and I divided them into 2 categories as 2019 and 20. Then I check whether my dependent variables are continuous. I saw that I have continuous and interval variables, so then I checked my third and fourth assumption, which are: there should be no significant outliers in the difference between 2 related groups, and the distribution of the dependent variables should be approximately normally distributed. So I calculate the difference to see if it's normally distributed, and I draw a box plot to see if there is any outlier. As you can see it in here, I use the difference variable to draw this plot, and I found that my curve type is almost symmetrical, and I found out that I have 1 outlier in this test. So if I would think this will affect my results of the test, and if there was only a limited number of outliers, it would be possible for us to remove those outlier variables from our tests. However, I decided not to remove it, as I realized that it did not significantly affect the results, because I tried both ways and I saw that result. So after identifying this outlier, I am no longer interested in the difference, and I did my t-test from here and checked its normality. So I will show you this now. I used variable pairs to conduct the t-tests, and if our dataset is normally distributed, significance level should be less than 0.05. Our significance level measured in here with p, and as you can see, it is smaller than 0.001. So we can say we found that our data set violates normality assumption. And also I checked the normality assumption and saw the same result. As you can see it in here, it's bigger than 0.05. So it is violates the normality assumption. Here I conduct two-tailed tests and I have two unequal measures. As a result, I saw that null hypotheses and alternative hypotheses are not the same. Finally, I add effect size, classical effect size, and confidence interval to test for my report. By looking the coherence D, we can say that it's a large effect since D is minus 1.318. So when we look at the data in general, we think that October 2020 is colder in London compared to 2019. So I did a pair t-test to see if this change is statistically significant, and at the end of the test I found that significant difference between the pre-test and post-test mean scores. As you can see in this table, we have mean values in here, and there is a significant difference between those. So for example, if our hypothesis is that London is colder in October 2020 because of some kind of wind effect, after this test we have obtained a meaningful statistical result in favor of this hypothesis.